Hi and welcome to leg injury prevention training. We will do always an exercise against leg injuries and always exercises of standing on one leg. And then we're going to read from here something to adiabatic process and the uncorking of champagne bottles and participating in exercises, etc. on risk. So it's about the physical aspects of it. And we're starting with a warm-up exercise. We're just breathing in, going down into the knees, coming up. And breathing out again. And we're repeating the cycle. Breathe in. And again, out. And again. Out. One last round. Breathe in. And out. Now breathe in, close the legs. And we can start the first exercise. So we are doing a standing leg. The upper leg is with a flexed foot in the air. Then we're swinging with leg to the side. So here to the side. And here in front. To the side. And in front. And the toes of the leg, which is swinging, are pointing more or less the whole time in front. Just swing it. A few times more. And now we're changing to the other leg. So this exercise is not so much for the leg which is swinging, which is doing the big active visible part. Only a little bit to improve the mobility. But the standing leg, because the standing leg has to work against all the force which are going side to that side of the knee, has to strengthen all the things. So that's an exercise for the standing leg. And that's the last time. So now to the adiabatic process and the uncorking of champagne bottles. Champagne bottles exist and they are oftentimes closed with a cork. So that was in the title. So champagne bottles exist. These are bottles filled with a liquid or a beverage which is called champagne. And they have a cork up in the neck. So they are closed not with a lid or something, but with a cork. And they are made of different materials, but they can be actually made from trees. So they are closed with something put into the bottle openings so that it can't come out. A champagne bottle can be cooled to 6 degrees Celsius. So they are oftentimes cooled, not at room temperature or outdoor temperature, going up and down, but they are sometimes cooled down, and they are pretty precise here. In this example case, that are 6 degrees Celsius. The next exercise, we're having again a standing leg. As I said, all the exercises are standing on one leg. The other legs again in the air, the flexed foot. We bring it in the front and back, front and back. We're doing it quite fast. And as it gets a bit, it's again not so much an exercise for the leg which is doing the big movement, even as it is. It has quite something to do. It's again an exercise for standing leg. The ankle has to learn to react to different forces from the side coming and so on. And with the whole leg absorbs and the muscles work, but if there's a bad step, not everything goes onto the ankle and we are falling down or something. No, it's not about falling down, only it's about getting an injury to the ankle. Exercise. We don't fall. First we have changed the leg. So it's about that the ankle doesn't bend over, or what it's called. Because it's stable chained and the force goes over into the leg and the whole leg holds strong against it. And because the ankle doesn't bend over, which will injure the ankle, we also don't fall down. That is the hopefully idea. Now back to here. In the body of the bottle is the liquid. Then in the neck is a little area between the cork at the top of the bottle and the liquid in the body where carbon dioxide is. So the bottle has in the body the champagne or something, and then in the neck there's the cork, and between the liquid and the cork there's a little area where no liquid is. So it's not completely filled up, but there's a little area left, and there is carbon dioxide. There's carbon dioxide. The content inside the bottle is under pressure. For example, 4.5 bar. Not only the liquid, but also the carbon dioxide in the neck of the bottle is under 4.5 bar, 4.5 bar pressure. So the liquid is not just in there, but it's under pressure in it. And with in our example, 4.5 bar, 4.5 bar, 4.5 bar, 4.5 bar, 4.5 bar. Next exercise. We are bringing one leg up into a right angle with a flexed foot. We have an even aligned hips and a tall back. And now we're bringing that leg to the outside. we're breathing in. And out again, the leg back into the middle and control down. We're going to do it again. The leg up, right angle flexed foot, even line hips tall off the back. Bring the leg to the other side, breathing in. And out again, back into the middle and down. The breathing is just to measure the time. Our leg up, right angle of the leg, flexed foot, even line hips tall off the back. Back to the leg to the outside, we're breathing in. And out again, back into the middle, control down. And last time. Leg up to the outside, we're breathing in. And out back into the middle, control down. So all inside of the bottle, the champagne and the carbon dioxide between the cork is under 4.5 bar pressure. The normal pressure in the area, as it appears to be indicated in the text, is 1 bar. So here's everywhere 1 bar, and in this bottle are 4.5 bars, so 5 times more pressure than in the normal area. So something like that is written in the text later on. When the cork of a bottle is removed, the carbon dioxide is no longer under 4.5 bar, but just 1 bar. The 1 bar is the amount of the ambient pressure around it. So here is it written. So ambient pressure, as it's called, is the pressure around it. Ambient means something like the surrounding pressure. So the pressure around of a bottle, which is guessable because the champagne bottle is opened under normal conditions, is 1 bar. And so in bottle 4.5, out of the bottle 1 bar. If the pressure is no longer 4.5 bar, but just 1 bar, the carbon dioxide expands. This expansion is in the source material described as the adiabatically pressure. So it is compressed inside of the bottle, and if you're opening the bottle, it can come out, the carbon dioxide comes out, and it expands because it's no longer together, it expands. Next exercise, we're bringing again the leg up, right angle flexed foot, even line hips, taller with the back. Now we're pressing the inside against the knee, and we're having a little bend at the other. And we're switching. The other leg up, right angle of the leg, flexed foot, even line hips, taller with the back. Little bend in the elbow, we're pressing against the inside of the knee. And on to the next exercise, very similar. Leg up, right angle of the leg, flexed foot, even line hips, taller with the back. Now the knee presses up into the hand, to the side, into the other hand. Up to the side, up to the side. A few times more, taller with the back, even line hips. And we're switching to the other side, our leg. Leg up, right angle of the leg, flexed foot, even line hips, taller with the back, and the knee presses into the hand, into the side. Side, up, to the side, up. Okay, back to here. When the carbon dioxide expands because it is under less pressure, it cools down. That can be to minus 75 degrees Celsius. So through this aptically cooling down, brings it down to minus 75 degrees Celsius. So the bottle inside, the carbon dioxide had 6 degrees. But if something expands, it cools down. So it expands very fast, very rapidly, from 4.5 bar to 1 bar. So it expands because it's not pressed together. And this expansion cools things down. If things expand, they cool down. If they are compressed, they heat up. So it cools down to minus 75 degrees Celsius. Now we're placing one hand on the tummy and one on the back. And we're bringing one leg up. The leg is straight with a flexed foot. If the quad cramps, bring it up and point the foot. We're bringing the leg up. Effort into controlling with the hands. We don't go back, but we have a neutral position for the spine. And put a bit of effort into bringing the leg higher. Now we bring it up and we bring the leg up and we're having a pointed foot. And with the other leg. The leg up. Straight leg, flexed foot, control with the hands. But you have a neutral position of the spine, and try to bring the leg higher up. And bring the leg up, and point your foot. At the opening of a bottle, the temperature drops below the dew point. And the dew point means that the water in the air condensates to little water droplets. So the air cools down around the opening of a bottle. So the carbon dioxide comes out, it expands because it's not under so much pressure. And the expansion cools everything down around the opening of a bottle. And that cooling down leads to the dew point happening. And at the dew point, water in the air, I think it is condensation, condensates to dew. The water droplets and maybe also ice crystals are as a white-grey cloud around the bottle's opening visible, and that is visible as the next exercise. We're having a standing leg, the toes are pointing to the outside. The heel of our leg is with the heel on the ground, and we're lifting the heel off the ground, and we're placing it again on the ground and down over your gluteus medius, I think. So, carbon dioxide has 4.5 bar if a bottle had 6 degrees. And when it's opened, this 4.5 bar expand because they are not under that much pressure. They are under pressure of 4.5 bar, and now we are on the air only under 1 bar. So they expand. And this expansion leads to cooling down. And that cooling down also cools the air around it down. It's switching the leg. And that cooling down of the air leads to that ice crystals are forming and water droplets condensate because the water in the air condensates to dew because it got colder. And that is visible as a little white grow cloud around a champagne bottle. The text is not that precise about how often that happens, so it seems not to be guaranteed, but in theory. If a champagne bottle has not 6 degrees when it's opened, but 20 degrees Celsius, the pressure in the bottle has instead of 4.5 bar 7 bar. The adiabatic cooling down for the greater pressure difference from 7 bar to the still unchanged 1 bar ambient pressure is stronger because the sun expansion for carbon dioxide after opening of a bottle is greater. The carbon dioxide cools down to minus 90 degrees Celsius. When the carbon dioxide has cooled down to minus 90 degrees Celsius, something called dry ice is as blue coloring at the neck of a bottle visible. Ice consists of water and melts at 0 degrees Celsius. Dry ice consists of carbon dioxide and melts at minus 70.5 degrees Celsius. But it does not melt the water. Dry ice is solid carbon dioxide and at minus 78.5 degrees Celsius becomes from being solid dry ice carbon dioxide as a gas. If something solid like ice out of water becomes at 0 degrees Celsius liquid water, that is called melting. If something solid like dry ice out of carbon dioxide at minus 70.5 degrees Celsius gets to a gas state, that is called sublimation. I don't have that much time left. The last exercise. We're having a standing leg and we're bringing the other leg, which has a flexed foot, up into the air, and the upper part of the body goes down in a straight line. And the standing leg is taught to bring the pressure onto the biceps femoris of hamstrings. And now we're changing. Few more. And last one. And now the closing exercise, the opening exercise. Breathing in. And in. Out. Breathe in. Out. Now breathe in and cross the legs. And we're done with the leg injury prevention technique. So, if a champagne bottle had 6 degrees, the pressure in it was 4.5 degrees. If it had now 20 degrees, the champagne inside of the bottle and the carbon dioxide also 20 degrees, the pressure inside of the bottle is greater because it was warm. And now because the pressure is greater, I think it was 6 or 7 bars, it's not important, and the expansion is greater. So it had, let's say 7 degrees, 7 bars, 7 bar, way stronger than 4 bar. Now it expands way more rapidly. And the expansion is greater, so it cools down more to minus 90 degrees. And if carbon dioxide is lower than minus 70.8 degrees, 0.5 degrees Celsius, then it becomes dry ice. And dry ice is visible then so carbon dioxide is then dry ice, not water, dry ice, made of carbon dioxide, as a little blue coloring at the neck of a bottle. And for the face position, Solid to liquid is melting, liquid to solid is freezing, solid to gas is sublimation, gas to solid deposition, liquid to gas vaporization, gas to liquid condensation, gas to plasma ionization, plasma to gas recombination. Because the dry ice becomes directly carbon dioxide, and carbon dioxide is gas. Water is liquid, carbon dioxide is gas. So if ice melts to water, and dry ice subliminates, something like subliminates, I guess, to gas. So there are different names for it. I thank you very much, until the next time.